So sometimes direct substitution does not work. So I'm going to kind of ignore the directions here and just try direct substitution. So if I wanted to look at the limit as x approaches 2 of x squared plus 3x minus 10 divided by x minus 2, and I wanted to try to calculate that using direct substitution, that would look like 2 squared plus 3 times 2 minus 10 all over 2 minus 2. In the numerator, looks like I would get 4 plus 6 minus 10. And in the denominator, I would get 0. And at this point in our mathematics career, we know that this is a problem, right? We cannot divide by 0. So that tells us that this strategy that we've used thus far is not going to work. Okay, so we're actually going to look at in the next examples, I believe it's 6 through 9, at this method number 2 for analytically evaluating limits, this idea of factoring and canceling. Okay, so I notice that that function that we're taking the limit of has a numerator that is a factorable quadratic. Okay, so that statement, the limit as x approaches 2 of x squared plus 3x minus 10, all divided by x minus 10, x minus 2, is the same thing as the limit as x approaches 2 of x plus 5 times x minus 2 all over x minus 2. So what happened here to here is I recognize that x squared plus 3x minus 10 can be factored into an x plus 5 times an x minus 2. And what you'll see is that there's a common factor in the denominator and numerator of x minus 2. So we can cancel those shared factors out and say that this is equivalent to the limit as x approaches 2 of x plus 5. Now we can go ahead and try this direct substitution. So we'll grab that c value and we'll plug it in anywhere we see x. So just in that one spot, we'll see that the limit as x approaches 2 of x plus 5 is 2 plus 5, or 7. Okay, so what this means is that the limit as x approaches 2 of our function, f of x, which was given to us by this quadratic x squared plus 3x minus 10 over x minus 2, we know that the limit of that function as x approaches 2 is equal to 7. And at this point, if you're watching this video, I would pause and take a look at the guided notes as they're posted on Classroom to see what does this fact mean graphically, and what is happening on the graph because of this cancellation of x minus 2 up here. Okay, another example here. It's pretty quick to notice, hopefully, that if we do direct substitution, if we do 4 times 0 squared minus 4 times 0 over 0, we're going to run into that problem again of division by 0, and that's not going to work. Okay, so we're going to see how can we factor that function into something that we could then use direct substitution with. Okay, so we have the limit as x approaches 0 of 4x squared minus 5x over x. And I'm going to use my denominator to guide what I want to do. I know that there is this x in the denominator that's causing the problem, so I want to see if in my numerator I can somehow take out an x that would cancel with the x in the denominator and get rid of that. And in fact, there is. We can see that, that limit that we have written is the same as the limit as x approaches 0 of x times 4x minus 5, all divided by x. And in recognizing that greatest common factor, right, of x between those two terms in the numerator, we can simplify and reduce that problematic x from the denominator. So this tells us that this is equivalent to the limit as x approaches 0 of 4x minus 5. And from here, we can see with not too much work that direct substitution will now work, and we'll get that the limit as x approaches 0 of 4x minus 5 is just negative 5. So again, our conclusion is that the limit as x approaches 0 of our original function is equal to negative 5. Oh my goodness. Okay. And again, please make sure that you're checking out what's going on graphically with this. You should hopefully see a hole at x equals 0 from this factor, and you should see, though, that the function 4x squared minus 5x over x is approaching the value of negative 5 as x goes to 0. All right, so here again we have an issue. If we try to use direct substitution right away into that denominator, you're going to see that that will give you negative 7 plus 7, which will give you division by 0, which we've discussed as an issue. So we need to see what we can do as far as factoring this goes. Again, I'm going to use that denominator to kind of help guide my work. I'm hoping to cancel that out. So if things are working or behaving nicely, I should have a factor of x plus 7 in my numerator. So we'll take the limit as x minus 7 of 2x squared plus 13x minus 7 over x plus 7, and we're going to work to factor the numerator. Okay, I know that my factors are going to have to lead off with a 2x and an x, so that when I FOIL back out, I obtain the 2x squared to start my quadratic. And I know I'm going to have a 7 and a 1 either filling spots like that or flipped, right? I could maybe have my 7 over here and my 1 over here. Because in my denominator I have this x plus 7, I'm going to see if creating this or forcing that to be x plus 7 is going to work. I see that my quadratic is supposed to have a c value of negative 7. So thinking about how numbers behave when we multiply, I need to decide what symbol goes here. Is it plus or is it minus? So if I were to FOIL this in one step of foiling, I would be taking 1 and 7 and multiplying them together, and I need that to be negative 7. So that tells me that a negative 1 needs to exist in this factor. So that allows me to rewrite this as the limit as x approaches negative 7 of 2x minus 1 times x plus 7 over x plus 7. And in that work, we got the common factor that we can cancel, which allows us to rewrite this as the limit as x approaches negative 7 of 2x minus 1. And now we're in a place where we can go ahead and utilize that direct substitution, plugging in our c value everywhere there's an x. So we can evaluate that limit to be 2 times negative 7 minus 1, which is negative 15. That allows us to make the claim that the limit as x approaches negative 7 of 2x squared plus 13x minus 7 all over x plus 7 is equal to negative 15. And again, it would be a good idea to pause the video and check out what's happening graphically. You can see all of these how all this affects the graph in the guided notes that are posted. Okay, one last one for factoring and canceling. It's a little bit more complicated. It's not quite as obvious that there's an issue when you plug in -2 in the denominator, but we can go ahead and quick verify that. Notice that if you take 3 times -2 squared plus 6 times -2, you're getting 3 times 4 plus a -12 here, or you could write that as -12, and you see that this is 12 minus 12, which is 0. So we do have that division of 0, which is telling us that the direct substitution is not going to be possible quite yet. So again, we need to look at how can we factor, in this case, the numerator and denominator, it seems, to get towards something that would support direct substitution. Okay, so in writing this down, I noticed that every single term in my numerator and every single term in my denominator has an x, right? So I can go ahead and identify a greatest common factor of x in the numerator and denominator. And I'm just going to take this step by step. So I'll go ahead and rewrite this as the limit as x approaches -2 of x times 3x squared minus 6x minus 24, where all I've done is I've divided an x from each term of the numerator and also the denominator. Okay, this allows the cancellation of at least the x's, and that leaves me with the limit as x approaches -2 of 3x squared minus 6x minus 24 all over 3x plus 6. And here I noticed that maybe that was a silly first step because there's still another greatest common factor of 3 in both numerator and denominator. I could have combined this greatest common factor of x and this greatest common factor of 3 into a single greatest common factor of 3x and divided it all out at once, but I didn't. So I'll go ahead and take care of that -3 now. So dividing every term in the numerator by 3, I will get 3 times x squared minus 2x minus 8 all over 3 times x plus 2. And again, we have that nice cancellation happening of the 3's, okay? So that'll leave me with the limit as x approaches -2 of x squared minus 2x minus 8 all over x plus 2. And it seems like we've done a ton of work, and it might be tempting to say, all right, I'm going to go ahead and plug in my -2, right? I'm going to see if all of this work up here has led me to a point where I can go ahead and use direct substitution. Well, under quick inspection, right, you see that -2 plus 2 is still 0, so we're not quite ready to do that direct substitution. Instead, we're going to see if this numerator can factor. So the limit, this will become the limit as x approaches -2. I'm assuming that x plus 2 is a factor of that numerator and that it will cancel with this x plus 2 in the denominator. At least I'm hoping that's the case. And if you look at the numbers, right, we need something to multiply to -8 and add to -2. So we can fill this first factor with x minus 4. In doing so, we finally get to get rid of that troublesome 2 in the denominator, and we're left with the limit as x approaches -2 of x minus 4, right? That's what we've reduced our function to be. And at this point, there's no issue with direct substitution, right? -2 minus 4 is just -6. So a lot of work, but we're able to say that the limit as x approaches -2, and I'm going to run out of room, so I'll go ahead and scoot that over. All of this work tells us that the limit as x approaches -2 of 3x cubed minus 6x squared minus 24x all over 3x squared plus 6x is equal to negative 6. Okay, one thing that I want to make a comment about before I pause this video is that in every single step, until I'm ready to actually plug in the -2, I had to write the limit. Okay, that is super, super important. In this purple step, I'm still wondering what the limit is. And in this dark purple step, I'm still wondering what the limit is. In both of these red steps, I haven't evaluated, so I need to continue writing the limit sign. Right? That limit notation is important and necessary in every single step until I get to the point where I can just plug it in. Okay, so that's super, super important, and there's a bunch of like orange boxes detailing that step on your guided notes. At this point, I would go ahead and pause the video. Well, I guess it's almost over, but stop the video and see if you can't do these practice problems. There's an answer key posted on Classroom that you can utilize to check.